The quadratic Euler product is a representation of the Riemann zeta function that arises when considering the values of the zeta function at the half-line, where the real part of the argument is 12. This representation is particularly important in the context of the Riemann hypothesis, which conjectures that all non-trivial zeros of the zeta function lie on this line. To understand the quadratic Euler product, we first need to recall the Euler product formula for the Riemann zeta function. This formula expresses the zeta function as an infinite product over all prime numbers, zeta s pi p1 ps1, where the product is taken over all primes p, and s is a complex number with real part greater than 1. The quadratic Euler product is a modification of this formula that arises when considering the values of the zeta function at the half-line. It is given by the formula zeta 12 at pi p1 to 1 pa theta pt1 to 1 pei theta pt, where the product is taken over all primes p, t is a real number, and theta pt is a certain phase factor that depends on p and t. The quadratic Euler product formula reveals a deep connection between the zeros of the zeta function and the distribution of prime numbers. It shows that the behavior of the zeta function at the half-line, where the Riemann hypothesis predicts all non-trivial zeros to lie, is intimately tied to the arithmetic properties of the primes. Despite its simplicity, the quadratic Euler product formula encapsulates much of the mystery and beauty of the Riemann zeta function. It is a central tool in the study of the zeta function and its zeros, and it continues to inspire much research in number theory and related fields. The quadratic Euler product formula is also closely related to other important concepts in number theory, such as the explicit formulas for prime number counts in terms of zeros of the zeta function, and the theory of L functions and automorphic forms. These connections highlight the fundamental role of the zeta function in the arithmetic of prime numbers, and the deep interplay between analysis and number theory in the study of the zeta function.